So I'll be doing question 2 of the 2005 AP Calculus test. We'll start by reading the question. A water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. During the time interval 0 is less or equal to t is less than or equal to 18. Water is pumped into the tank at the rate. So the initial condition is 1,200 gallons of water at 0 hours. And the first thing they give you is the rate in. So W of t equals 95 root t sine squared of t over 6 gallons per hour. So we'll write that down. It'll be W of t equals 95 root t sine squared of t over 6. And remember that this is your rate in. So the first thing you want to do is define this in your calculator, meaning you don't have to retype this every time. And when you do it on the calculator, you have to rewrite it so that it can actually understand what you're saying. So as opposed to saying W of t equals 95 t sine squared t over 6, you're actually going to rewrite it because it won't understand what this means. So when you rewrite it, you're going to move this, and it's going to mean the same thing, but it's just so that the calculator can understand. So both of these are going to be squared, and then you should be able to get a definition of this. So next thing that they give you in the question is the rate out. And so that's R of t equals 275 sine squared t over 3 gallons per hour. So this is going to be your rate out. So R of t equals 275 sine squared of t over 3. And this is your rate out, remember? And remember, you're going to define this so that it's easier to deal with instead of having to retype it. So same thing, you're going to have to rewrite it so that the calculator can understand it. So it's going to be R of t colon equals 275 parentheses sine, parentheses sine of t over 3 squared. And now you have your two definitions, W of t, your rate in, and R of t, your rate out. And so now you can actually start answering the questions. So the first question they ask you is the amount of water in the tank increasing at time t equals 15, why or why not? So what you want to do is you want to see what they're asking you, and they're looking for a rate of change. So that would be the total rate of change, shorten it ROC for rate of change, will be W of t, which is your rate in, minus R of t, which is your rate out, right? And they gave you a specific time, 15 hours, so it'll be W of 15 minus R of 15. So you go to your calculator and you type W of 15 minus R of 15. And that gives you negative 121.09. gallons, right? And so what that means is, we'll write it right here, negative 121.009. This value is less than 0, right? Meaning that the water in this tank is not increasing, rather it's decreasing. Right? And this is because the value of R of t was greater to that of WT, your rate in. Right? So that means you're losing more than you're gaining. And so you're going to have a decreasing level of water. Right? So your next question. Question B, to the nearest whole number, how many gallons of water are in the tank at time t equals 0? So this is where the integration starts happening. And so you read your question and you realize that you have an initial condition of 1,200 gallons of water at 0 hours, right? So you'll have an initial 1,200 plus whatever the difference is, the rate of change is between the rate in and the rate out. So you're going to have an integration from 0 hours to 18 hours, and it's going to be, this is where your rate of change comes in, W of t minus R of t, right? And it's going to be in respect to t, time, and you get 1,309.79, right? So that is how many gallons of water in the tank at 18 hours. But remember that they asked for the nearest, gallon. So this will go to approximately 1,310 gallons, right? So that was B. That one was pretty good, easy. I mean, you just had to remember to make sure you're integrating and you have your ranges in hours to time, right? And then your final answer, which was 1310, sorry. Okay. So part C. At what time t for 0 is less than or equal to t is less than or equal to 18 is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. Okay, so we'll start by saying that we can make this some arbitrary value. So we'll say let C of t equal 1,200 plus 0 to whatever t value, right? And then it'll be the rate of change, the W of t minus R of t in respect to time, right? And we'll let C of t be this, which will be the water in the pipe at t, which will range from 0 to 18 hours. Okay? So if you take the derivative of this, you will get c prime of t equaling your initial rate of change that we've been dealing with, right? Because 1200 was a constant, and the difference between a integral and derivative will just be what was in the integral, right? Which was the rate of change. And so now you're going to do a candidates test. Okay, so you're going to find all the places that W of t minus R of t equals 0, right? So now we can start making the candidates test. So you'll have t and then c prime of t. And you can already put 0 and 18. And that the initial was 1200. And we found out from part B that at 18 it would be 1310, right? So now we go to our graphing document, add graph, and we will say, we'll make our lines now, our function. And so the W of t will be 95 square root of x, because right here it's f of x, so we'll keep it x, but it's going to be the same thing. Sine of x over 6 squared. So this will be our first function. And then we add our second function. Same thing, it's going to be x instead of t, but it's the same thing. 275 sine x over 3 squared. So now we have this. So now you're going to find when you're going to try and find where W of t and R of t minus R of t equals 0. So that means they're going to be where they're the same value, which means you're going to look for where they intersect, because that means the y values are going to be the same and they'll equal 0, right? So when we do that, we're just going to look for an intersection. So we can go here, and there's no intersection here, so we can start here. And we'll drag. And you see how it highlighted intersection right there? That means we passed an intersection. So now we see that there's an intersection at 6.49. So we can put that in t. So 6.49 as a time where it's 0, where c of t equals 0, c prime of t equals 0. And now we can come back and we're going to just scan to make sure that there's no other intersections. And remember, we're only going to 18, so we can come pretty close. Okay, so here's 22, so we can go from right here again. And we'll go to Analyze Graph, Intersection. And we'll come here this time. And we'll see where it highlights intersection, and it highlights right there. So that means we passed an intersection. And this one says that it's at 13. So we can come back to our table and mark that they're at time equals 13 hours. There will be another point where c prime of t equals 0. Okay. So then we can go back. We go back to our calculator and we put it into this, an equation like this, right? And so we'll say 1200 plus integral from 0 to 6.49. We're looking for this, so we can even highlight that. And we'll say this in respect to time, right? And we get 525. So at time equals 6.49, we get 525. And then the same thing for 13. So we can copy this if you want, just physically type it, but I'm just going to copy it for the sake of time. I'm going to put it to 13. And we get 1,697. And we'll put 1,697. And on the candidates table, you can see that at 6.49, this is our minimum value. So we found it, right? This is the absolute minimum, 525 at 6.49 hours. All right, so now we can go on to part D, which reads, for times less than 18, no water is pumped into the, or greater than 18, sorry. So that means we're past the initial 0 to 18 hours. So for time greater than 18, no water is pumped into the tank, but water continues to be removed at the rate R of t, which we said was the 275 sine squared t over 3, until the tank becomes empty. Let k be the time at which the tank becomes empty. Write, but do not solve an equation involving an integral expression that can be used to find the value of k. So we can come back and we say that, so we're making an integral, right? From 18, because we passed the initial 18, to k. This is the unknown time that we don't know how long it's going to take, right? Let k be the time at which the tank becomes empty. This is the final time that it becomes empty. And now we're just following the rate out expression. So that would be R of t, right, in respect to time, equals the 1310, which we said was how much would be in the tank after 18 hours. Remember? So 18 hours, we said that there was going to be 1,310 gallons. So this expression shows the time it'll take, or the final time it'll take to remove this 1,310 gallons. So this would be your expression. And that's it. Right? Thank you, and I hope you enjoyed.